So now, after computing what could be the future needs of each process, we look at what we currently available from the resources versus what could be requested by the processes, and compare, given these available resources, can we fulfill any of the processes the future needs? We would notice that with 332 available, we cannot fulfill P1 because it could ask for 7 instance of R1 and we only have 3, so that's one reason. There are other reasons why we could not fulfill this. And the same thing, we cannot fulfill any the future request of P3 because it could request 6 of R1 when we only have 3. However, and similarly for P5. However, looking at P2 and P4, given what we have, we can fulfill one of them. So let's pick one. Let's say that we're going to fulfill P2. So if we fulfill P2, we give it what it needs, the 122 that it needs. So if we gave it 122 from what we have, and then let it finish. Once it finishes, how much extra do we get? We will get those 122 back plus what was allocated to that process earlier. So our available resources now will increase by 200. So now we have 5, 3, 2. That's the new availability after P2 completes. So I'm going to write that P2 has completed, and I have a sequence that starting from P2 we reach this new available resources. We keep doing this for the remaining checking this for the remaining resources. So given the 532 availability and processes B1, B3, B4, B5 are still to run, can we fulfill any of its resources? The answer is clearly we can do it with maybe B5, because it could only ask for a maximum of 431 additional, and we have 532. Or we can do it with B4. So let's do it. Let's choose one. You see, the objective is to find at least one sequence. We don't have to find all sequences. So if we choose P5, for example, so I'm going to write here B5, then we can give B5 its 431 that it needs from the 532 that we have, and let it finish. And when it finishes, it's going to release everything that it has. So in addition to the 431 that is going to release, it's going to release 002 as well. So our availability now becomes 534. And this is the new availability vector, and B5 is done. So with 534, what can we satisfy next? I think we can do B4, because it could only demand up to 011, and if it does that, we allow it to complete, and it's going to release 211 additional resources on top of what we have. So if we let P4 to run, it will increase our availability by 211, and we end up with 7, 4, 5. So that's the new availability, and B4 is done. So given what we have, 7, 4, 5 now, and we only have 2 processes to satisfy their future needs. Can we satisfy any of them? In fact, we could go with any one of them. So I'm going to go with the with P1. So if I fulfill the maximum needs, the maximum future needs of P1, which is 743 from the 745 that I have, and let it complete, P1 will release the 743 plus the 010 that it already had. So when P1 completes, we end up with 0, 1, 1 extra resources. So that's a total of 7, 5, 5. Sorry, we get 0, 1, 0 extra resources on top of our 7, 4, 5, leading to 7, 5, 5. And P1 is done. So now with the new availability 7, 4, 5, 7, 5, 5, and process P3 remaining that has not been given a chance to complete yet. Can we fulfill its demands? Apparently we have more than what it needs, so if we let it run, we will give it the 600 that it needs, and after it completes, it's gonna release those 600 plus the 302, so we end up with the following when P3 completes. We end up with, if we add 302 extra, we end up with 10, 5, 7, and P3 has completed. Now, do we have any more processes that need resources? The answer is no. So all processes could complete, and we have the sequence P2, then P5, then B4, then P1, then P3. So we could find a sequence through which all currently active processes could complete if we started from this state. Therefore, we label this state, the original state, as a safe state. The state before I did all these calculations, that is a safe state. So this technique is important because in the following banker's algorithm, we will have to answer a question. Given a state defined by these matrices and vectors, given a state, is it safe or not? And this illustration shows how we can answer this question. Thank you.